Welcome back to another video in PDEs. Now we are going to solve a non-homogeneous when actually we have a time-dependent function. In the previous, it was time-independent because we didn't have the variable time, but here we have variable time, so it's time-dependent. So how do I solve? I have the boundary conditions and I have the initial condition. As before, first I'm gonna say, okay, I'm gonna introduce a new variable. I'm gonna say uxt has to be equal to vxt plus some function phi. Now this time, this function phi will be depending on x and time. Now the next step is to introduce some function phi. Previously, as you remember, we would like do derivatives and then solve for phi. But now here, instead of solving for phi, you actually you force the function. I'm gonna force phi to be a linear function that depends on the boundary conditions. So I'm gonna say, okay, I'm gonna explain. Now, if you have the boundary condition u0t equal to u some function of time t, and then u at the end, the other boundary is, for example, another function. I'm gonna say here is u0, here is u1t. I want to build phi to be, I want to force phi to be 0 naught x over L u1 minus u0. I want it to have a linear relationship with for the boundary conditions. That's how you build your phi function. So xt is gonna be u0 is the value of the first boundary condition, 0 plus x over L 0, 0. So we end up with 0. So phi xt is 0. We are lucky we ended up with 0 because the boundary condition given here is just 0. So we are lucky that we ended up with 0. So that's great. Now, next step, I'm gonna do uxt, then it's gonna be just vxt. If I sub to the original equation, the equation becomes okay, so we have this problem with v, so nothing really actually changed. But for v condition, it's still the same because uxt equal vxt. So that means the condition for v are also the same. Okay, now I'm gonna take this function and I'm gonna consider it to be some function gt equal to x minus 3t. Okay, now what I'm gonna do is search for a function for solution. If I look at the problems, so far everything we've been using, we just end up with Fourier series, right? So what I'm gonna do, I'm gonna just search for Fourier series. I'm gonna search for Fourier series for this problem. So if I look at the boundary condition, I don't see any derivatives. So we just can have idea that, okay, the problems that we solved that there was no derivative, we ended up with a signed Fourier series. So we just actually have to also guess to introduce them here. So what I'm gonna do is I'm gonna look for function v, which is the solution, has to be some Fourier series that I don't know. This is the coefficient. This is gonna be dependent on time because it's time dependent. Then I have sine n x. like that. Should be n pi x over pi, so pi with pi cancel, so just sign nx. Because as you remember, just to remind you, well, is sine pi nx over L. For the road, as you can see, the boundary condition is from 0 to L, so it's from 0 to pi, so your L equal to pi, so you just end up with sine nx, like that. Okay, also I'm gonna force this function gxt to be also some Fourier series function. I don't know vxt, so I don't do anything, but I know gx, so that means g, which is equal to the summation of n equal to 1 to infinity, some function gnt, sine of nx. From here, I can actually solve for this constant. It's going to be the integral 0 until pi. I should have outside the 2 over pi. Okay, I'm going to just put it inside 2 over pi. The function itself, gxt sine nx dx. Then gn 2 over pi integral 0 until pi gxt x 3t sine nx dx. Then I have 2 over pi times e to the power minus 3t is a constant, 0 pi x sine nx dx. Now this integral, I can just solve it by part or whatever method you want to use. Yeah, if you have any problem with solving integral, just let me know in the comments and I will make videos on how to integrate, how to master integration. Okay, this integral just solve quickly. I'm assuming you actually know it, because if you are solving PDEs, probably you know calculus, you know the basics of calculus. So
I'm gonna just solve this. I'm gonna go solve this problem. I have e minus 3t, and this is some integral I. Then I have I equal to 0 to pi x nx dx. So solve this integral. I just get as a result. Okay, this integral. I'm gonna solve first the indefinite integral, which is x sine nx dx. To solve this, I just have x integral sine nx dx, then minus cos of nx over n dx. Then I just have that the integral is gonna be minus x cos nx divided by n minus pi minus 1 to the power n over n, like that.
So that means my gn t function is equal to 2 over pi. Then I have e minus 3t times minus pi over n times minus 1 to the power n, like that. Then I have minus 2 minus 1 to the power n e minus 3t over n. That means the gxt function summation n from 1 to infinity gnt, which is just minus 2 minus 1 to the power n e minus 3t over n. Then all of these times n of nx. Then to organize everything, just become, the two can come out, summation n from 1 to infinity minus 1 n plus 1, because minus 1 to the minus 1, and then I have over n e minus 3t sine of nx. Okay, that's the gxt. Yeah, I'm gonna call it 1. That's a gxt. Now I know that Vx, as I wrote before, Vxt was equal to some function, also some series function, Vn also t nx. I need to solve the Vn. To solve the Vnt, I should use the Vxt, but I don't have the Vxt. So what I'm gonna do is actually, I'm gonna say this is 2. I need to sub 1 and 2. This is actually the general procedure that I'm showing you how to solve these type of problems. So I want to the original equation, to this equation, like that. Okay, then I have the original equation was that, oh wait, I want sub to, okay, I can use, I have to use this one that I transformed with V, which is just the same, like, because U equal to V. Let's just be organized. So I'm gonna just sub here to verify. Now, remember that this equal to G xt, right? That's what I said, which was equal to number 1, to this. Now, I just need to find this and this. Okay, delta V respect to x derivative, I have to find the derivative of 1 respect to x. So I have summation n1 to infinity delta x vn t sine nx. Now vnt is some function just of t, right? So I'm just find derivative just of sine x because the other one is gonna be a constant. So I have summation from 1 to infinity. So I have vn and cos of nx, like that. Now, second time, then I have summation. Again, I'm gonna have minus vn n squared sine of nx, like that. Okay, now I'm gonna find derivative in terms of time, the delta v over delta t. Then I have summation delta t of vn t sine of nx. Now this time sine nx is constant, so I just have to deal with I just have vn derivative in terms of time times sine nx, like that. Okay, now I have to sub all of them to this equation. So I have to do that. I have the first term is just this. What is it? Okay, this one. So I have summation minus vn, some function t, n squared sine of nx, like that. Then I have plus gxt. Gxt is the expression that I just solved. Minus 1. Like that. Has to be equal to delta v over delta t. Nx, like this. Okay, now I just have to actually solve for vt because that's the only thing I don't know in this equation. So to solve for vt, I'm gonna put everything with vt to one side.
So I have minus vn t n squared sine nx. Then I have minus prime t sine of nx equal to minus 2
Then from here, I'm gonna have infinity minus vn
n squared minus vn prime nx equal to infinity minus 2 e minus 3t sine of nx.
Okay, I have sine nx, I'm gonna just equalize the coefficient of each. That means I'm gonna have minus Vn has to be equal to minus 2 minus 3/2. Now, I'm just going to multiply both sides by minus 1. Then I have like that. Okay, I have this equation. This is just, I have to solve for Vn. Just remember, this is a linear ODE. It's a first order linear ODE. Oh, wait, I was forgetting, I have n squared here. Yeah, it's essential to have that n squared. Okay, remember how you solve when if you had, for example, first order plus some px equal to qx. This type of ODE is actually the same as the one that we have here, because we have, in terms of t, we have this first derivative, non-derivative, and then we have some function. So you actually have to solve it. You have to multiply by the integrating factor. Right, this integrating factor, multiply it, and then you have to deal with it. So it's the same procedure that I'm going to use here. So the integrating factor, nu is going to be e integral n squared dt. Like that. This is the integrating factor. Then I have e n squared t. So I'm going to multiply both sides by the integrating factor. Then I have t. Now here, this side is the same as Vn e n squared t in this side. So this will be equal to 2 minus 1 n plus 1 over n e minus 3t plus n squared, like that. N squared t, okay, like that. And also do like this, just to n plus 1 over n e n squared minus 3t. So I want to integrate both sides of time. Then I have Vn t equal to all of this is constant, so I just have 2 minus 1 n plus 1 divided by n. Then I have here n squared minus 3t divided by n squared minus 3 plus some constant c1. So then Vn t equal to, just to isolate. When you isolate, then n squared times t. Like you just multiply by this just to get rid of this, just to isolate. Okay, so that's your V and T. Yeah, unfortunately, it's kind of messy. So then I have just to write my VXT that I'm looking for, which is equal to UXT, as you remember in the beginning, is just the summation n1 to infinity VNT sine of nx. There's gonna be summation n1 to infinity. Then I have 2 minus 1
n plus 1 e to the power n squared minus 3t times e minus n squared t divided by n squared minus 3 plus c1 n squared t sine of nx.
Like that. Then from here, we can actually see that e to the power n squared into the power minus n squared is going to cancel. So let's have vxt equal to the summation minus 2e minus 3t over n squared minus 3 plus c1 nx, like that. Okay, now we have to find c1. I'm gonna use the initial condition. ux0 is just 0. As we remember that vxt was equal to uxt. So vx0 is gonna be just ux0, which is equal to 0. So I'm gonna sub to the equation, to this equation. I have vx0 summation of n equal to 1 infinity. I have 2 minus 1 n plus 1 divided by n squared minus 3. Because times e to the power minus 3t, which is just, okay, I'm going to just write it here. t is 0 plus c1 sine of nx has to be equal to 0. Then I have all of this as my coefficient. Then an equal to 2 over pi, 0 until pi. The function that was given for initial function, sine of nx, which is just 0. So that means c1 plus 2 minus 1 n plus 1 n squared minus 3 is just equal to an, which is 0. So isolate from here, minus 2 n squared minus 3 for c1. So that's your c1. Now I just need to use it to write vxt equal the summation unto infinity, and then let me just go back, then I have the function, then I can just write. I can write 2 just form and n plus 1 e minus 3t divided by n squared minus 3, and then minus, which is c1. c1 is minus 2 n plus 1 divided by n squared minus 3. c1 is multiplying e minus n squared t sine of n squared nx. Then ux is just the same as vxt, so just the summation of n equal to 1 to infinity. I just can do some factorization. Then I'm gonna have 2 minus 1 n plus 1 dividing by n squared minus 3 times e to the minus 3t minus e minus n squared t sine of nx. So that's the solution, as you can see.